I like to say that a smart home is not just IoT devices. For me, it is the whole system. The network, servers, backups, and all the little pieces that make the home actually work better. This was my old setup, pure chaos and a mess of cables, so I finally decided to get a proper server rack. After 5 seconds of research, I decided to get a big 42U server rack from Socomont. I chose a standard enclosed one without ventilation, since I plan to add my own. I went with the version with a glass door, but they also offer ones with a mesh door and a mesh back.
One eternity later.
It's huge, and I hope it has enough space for future expansion. I configured the maximum depth to 70 centimeters. It won't support the deepest servers, but I don't need that. It also has a 500 kilogram carrying capacity, which is enough for all the stuff I plan to install in it. Somehow it passed the wife's approval factor, so the rack will stay in the living room. My Homelab changed a lot over time, and like always, I thought the changes would be small. But once you start upgrading one thing, another thing suddenly needs to change. So today, I want to explain what each piece of hardware does, why I chose it, what I like about it, and what I still want to change in the future. So, let's jump into it. At the top of the network side is my internet provider's modem, the Freebox Delta. Connection speed can go up to 8 gigabits per second for both upload and download, but it's a shared channel, so real-world performance depends on the situation. In practice, it's often around 2.3 gigabits per second down and 800 megabits per second up. The modem is connected to my router using an SFP plus direct attach cable. The one thing I do not love about this modem is the power consumption. It uses around 20 watts all the time. So one of my future plans is to replace the internet provider's modem with a special SFP plus ONT module that can do everything the modem does, but with much lower power usage. Next in the rack is my backup router, the Sophos XG310. It's running pfSense, has two 10 gigabit SFP plus ports plus a lot of 1 gigabit ports. This was my old main router, and honestly, I still really like pfSense. It is powerful, flexible, and if you know what you are doing, you can make it do almost anything. But I wanted to understand and test the UniFi ecosystem, especially because I sometimes need to help clients with configurations. So for that reason, I bought a UniFi Dream Machine Pro and almost all UniFi devices from a local second-hand site, kind of like Craigslist. And I have to say I really like UniFi OS. It is easy to use. Sometimes it is a little bit confusing, especially when you know how something works in pfSense and then UniFi does it in a different way. But overall, it is simple, clean, and very fast to manage. UniFi has some features and workflows that are very specific to IoT networks, VLANs, and simple client setups, so I wanted to get more hands-on experience with it and test my IoT products. The Dream Machine Pro is connected to my 10 gigabit aggregation switch, and from there, all of the servers and NAS devices connects using an SFP plus direct attach cables. I chose SFP plus because it is efficient, cheap if you use DAC cables, and very reliable for short runs inside the rack. I do not really need 10 gigabit everywhere in the house, but inside the rack it makes a lot of sense. Backups, media transfers, VM storage can move around much faster. The only 10 gigabit connection outside the rack goes to my main PC, which is located in the next room and connected by fiber. Under that, I have a switch that I definitely want to replace. This one only has 1 gigabit ports, and even the uplink is just a regular 1 gigabit SFP port, which is not great at all. What I really want is a switch with 2.5 gigabit ports and at least a 10 gigabit uplink. The problem is that in the UniFi ecosystem, that kind of switch is not exactly cheap, at least not for me right now. So for the moment, this switch stays in the rack. It works, it does the job, but it is definitely on the upgrade list. I reserved space for a KVM switch because I know I'll add one later. Without a switch, whenever I need to manage a device directly, I have to move the display cable manually. So the perfect setup will be a KVM switch combined with a Jet KVM. Then I can select any machine in the rack and access it remotely without touching any cables. When I finally get it, I will probably make a small dedicated video about that setup. This 2U space is reserved for DIY stuff. I'm using a 2U frame that I think was made for audio racks, and then I 3D printed placeholders to mount everything cleanly. I'll put a GitHub page together for all this stuff and the configs. On the right side is my DIY rack cooling controller, and this is one of my favorite small projects in the rack. With this controller, I can check and change the rack temperature, monitor fan speed, and see whether the fans are actually spinning or not. The whole thing is based on ESPHome and uses PID control, so it stays quiet when the inside of the rack is not hot. And of course it integrates very nicely with Home Assistant. The next 1U space is occupied by two Lenovo thin clients. The first is used as a Proxmox cluster node, and the second as a general-purpose remote Windows PC. Both of them have PCIe slots, so I installed 10 gigabit network cards in them. Each one also has a 500 gigabyte SSD and 32 gigabytes of RAM, which is really nice considering RAM prices these days. Most of the time, they are actually turned off. That might sound strange for cluster nodes, but I use secondary nodes when I need to shut down my main Proxmox node for maintenance, updates, testing, or hardware changes. Now we get to my little beast, the ESPHome MSA2. This is my main Proxmox node, and it is powered by an AMD Ryzen 9 9955HX, a 16-core, 32-thread processor, which is kind of crazy in a machine this small. This node has 96 gigabytes of DDR5 RAM, two 10 gigabit SFP plus ports, 3 NVMe slots, and a full PCIe slot. I use that slot with an Oculink card to connect an external Intel Arc B50 Pro GPU. That GPU is used for small local LLMs and virtual machines that need GPU acceleration. If this video gets enough likes, I'll make a full video about all the services running in my Homelab. By the way, it's without the external shell because I found a 3D printed rack mount for this server, and I'm printing it right now. This little guy is the Wise 3040. I like to think of it as a tiny low-power SBC, but not ARM. It's x86, and nowadays it's about 15 times cheaper than a Raspberry Pi. It only has 2 gigabytes of RAM and 32 gigabytes of eMMC storage, but that is more than enough for scripts and a couple of Docker containers. Its job is to run the NUT server. It monitors the UPS, and when the power goes down, it can SSH into my router and servers and shut them down safely. That is really important because you don't want your storage or virtual machines to lose power instantly. The best part is the power consumption. This thing only uses around 3 to 4 watts, so it is perfect for a small, always-on management role. Next is my media and SMB server, the HP ProDesk 600G6. This machine has a 10th gen Intel Core i3, and right now I mainly use it for my full Jellyfin stack and as a central SMB server. In the future, I'll turn it into a dedicated Home Assistant server. This machine, with NVMe SSDs in RAID and one 2.5-inch enterprise SSD, uses only around 6 watts at idle. That is really good. It also has the possibility to add a 10 gigabit NIC, so there is room to upgrade the network later. If you want a powerful but power-efficient server for Home Assistant, Jellyfin, Docker containers, I think HP G6 Thin Client is a perfect option. For storing media files, I am using this external enclosure with one 12 terabyte and two 2 terabyte disks. It is not the most exciting device in the rack, but it does the job. One important note, if you buy one of these enclosures and you have problems with random disconnects, try changing the USB cable. The cable that came in the box was terrible. When Jellyfin used the full bandwidth of USB, the disk would start disconnecting. After changing the cable, it became stable. On the next shelf, I have two NAS devices. The first one is TerraMaster, and it has installed Proxmox Backup Server. This first NAS does not run all the time. Instead, it powers on every night at midnight, backs up all of my virtual machines, and then shuts down automatically after the backups are complete. This is one of the ways I try to reduce power consumption in the rack. Backups are important, but the backup server does not need to sit there using power all day when it only has one job at night. It has a 2.5 gigabit per second NIC, but unfortunately, because my LAN switch is only 1 gigabit per second, backups run slower and can saturate the switch uplink. This big boy is used primarily for video storage. It has great capacity and speed thanks to the 10 gigabit per second NIC, which is exactly what I need for video work. But all those spinning disks add a lot of power consumption. At idle, this NAS uses around 80 to 90 watts, because TrueNAS does not let the disks sleep the way I would like. For a main storage box, that might be acceptable. But for something that is mostly used to store video files, 80 watts all the time is not ideal. So this is one of those devices where I really appreciate the huge storage capacity, but at the same time, I'm always thinking about replacing it with an all-flash setup. Unfortunately, my wallet keeps talking me out of that idea. This 4U system is my editing and gaming PC. I recently moved my old PC into this rack mount case. It was basically the cheapest rack mount case I could find in Europe, but it has nice quality. The reason I put this system in the rack is because I want to use Apollo as server and Moonlight as client to connect remotely. If you do not know Apollo and Moonlight, think of it like a remote desktop, but with high frame rates and higher quality. It gives me the ability to use almost any old PC or laptop as a remote client, while the real power stays here in the rack. So I can edit videos or play games everywhere, as long as the internet connection is good enough. The next 3U is just a drawer for cables and other things. This is where I keep extra cables, adapters and screws. Nothing too special here. For a home lab, a UPS is not optional. It is one of the first things you should add once your setup has any type of PC, because it protects everything from power cuts and gives the NUT server enough time to shut down systems safely. This UPS can deliver up to 1.5 kilowatts of pure sine wave output, which is more than enough for my current setup. Without main power, it can run the rack for a couple of hours, depending on what is turned on at the time. I bought it used and replaced the batteries, which is usually a good way to save money. On top of the rack, I placed all of my wireless receivers and gateways: Zigbee, LoRa, Bluetooth, ESPHome, and LoRaWAN. For Zigbee, I'm using the new Home Assistant Connect ZBT2. So far, it has been very stable and has great range for my apartment. For Bluetooth sensors, I'm using a Xiao W5500 Ethernet gateway running ESPHome. It receives data from Bluetooth TPMS sensors on my bicycle, my smart scale, and several temperature sensors around the apartment. For ESPNow and LoRa sensors, I use my own designed gateway called CapiBridge. This is one of my own hardware projects. You can find the project video link in the description. I also want to play with public LoRaWAN network sensors, but unfortunately there is no public LoRaWAN coverage in my area. So I bought a SenseCap M2 multi-platform LoRaWAN indoor gateway. Hopefully when I have enough free time, I will design some LoRaWAN projects and test them with my own gateway. And that's the current rack side of my home lab. I hope you enjoyed this kind of video and found it interesting. If you have any questions, ideas or suggestions on how I could improve the setup, please leave a comment below. Thanks for watching, and I'll see you in the next one.